What's up, guys? Today we're going to be solving quadratic equations by factoring and then using the zero product property. So for this, as long as you know how to factor a quadratic trinomial, then you'll be good to go. Alright, here it is. Alright guys, today we are solving quadratics using the factoring method and using something called the zero product property, which I'll explain in a bit. Now, factoring is one of the first methods you learn when solving quadratics because it generally takes the least amount of time. And so when you're solving a quadratic, if you're given a choice of what method to use, you always want to try to see if factoring will work first. Because again, it sort of acts as a shortcut if you do have a factorable trinomial. And so remember, this is the general form of a quadratic equation, ax squared plus bx plus c equals 0. And when you're setting up the factoring method, you definitely want it to look like this. So you want all of your terms on one side and you want it all set equal to 0. And the reason for that is because of the zero product property that I'll get into in a second. So let's look at our first example here. Now notice how this quadratic equation is not set up in the standard form. And so that's going to be our first step here. So I want to get everything over to one side. And so I'm going to add 18 to both sides. Alright, and now we are in standard form. So now we can see that we have a factorable trinomial. Alright, so I'm going to go ahead and factor that. So remember, factoring is just the distributive property but backwards basically. So I know that this times this is going to give me an x squared, so I need an x and an x. And then since this times this is going to give me a positive number, I know that these either both need to be positive numbers or they both need to be negative numbers. So since I'm not sure which one to pick yet, I'm going to look at this number and I see that I'm also going to have to add to a positive number. And so I need positive, positive here. And then I need the factor pair of 18 that will add to 9, and that's going to be 6 and 3. Because 6 times 3 equals 18, and 6 plus 3 equals the 9. Alright, so we have just factored the trinomial, so that's all I've done. I haven't solved the equation, I've just factored it. I've just factored this expression here. And now this is where the zero product property comes into play. So simply put, this is the zero product property. Basically all it says is that if you have some number times a different number and it equals 0, then one of the two numbers has to be 0, right? So if a times b equals 0, then either a equals 0, b equals 0, or they're both equal 0. Whoops, there we go. All right, so just to illustrate this, let's say I had just two boxes, right? And I had some number times a different number and it equals 0. And I told you one of the numbers was 15, for example. Right? Then you know the other number needs to be 0. Because 15 times, there's only one number you can multiply 15 by to get 0, and that's 0. Right? And then similarly, if I told you that 0 times something equaled 0, well then you could put anything in this box, right? We don't even care what's in that box because we already know that one of the factors is 0, and 0 times anything will give me 0, right? So now back to the example here. Basically just think of these sets of parentheses as the boxes. Basically, this is saying this box times this box equals 0. And so one of the boxes has to be 0. And so what we're going to do is we're going to set both of the boxes. equal to 0. We're going to basically make two equations out of this. And then we're going to solve them for x. So I'm going to subtract 6 from both sides. And then I'm going to subtract 3 from both sides on this one. And so I have two possibilities. These are the x values that would make one of the boxes equal 0, right? If I substituted -6 in for x up here, then I would have -6 plus 6, which is 0. And then 0 times anything, we don't even care what that is at this point, will equal 0. And so that works. And then similarly, if I substituted -3 in for this x, then I would have -3 plus 3, which is 0. And then again, 0 times anything, we don't even care what that is, right? The -3, this x here would also be -3, and -3 plus 6 is +3, but it doesn't matter because 3 times 0 equals 0. And so it's important to note that this is or, right? X could be -6 or it could be -3. It can't be both simultaneously. All right, so these are your two solutions to this quadratic equation. And then you can check that. You could plug in -6 in for x up here, and you'll see that it's a true statement. You could plug in -3 up here, and you'll see that it's a true statement. All right, so we'll go ahead and move on to the next example here. So again, I'm not in standard form, so I want to go ahead and get everything to one side. So I'm going to subtract 10x from both sides. Oh, that should be a minus sign, because I want it to be in the center. All right, so I have x squared minus 10x plus 21 equals 0. And now I'm going to factor this. This is a factorable trinomial. And so I have xx, and then I'm this times this will give me a positive number here. And so they either both have to be positive or they both have to be negative, but I also need to add to a negative number, so they can't both be positive, they have to both be negative. And then the factor pair of 21, that will add to -10. Well, that's going to be -7 and -3. And now again, we're going to use the zero product property. So if this times this equals 0, then either this needs to be 0 or this needs to be 0, right? One of the boxes has to be 0. And so, you might just be able to see that, but just to be explicit, I'll write out the equations. So either x minus 7 needs to be 0, or x minus 3 needs to be 0. And then of course, we know that x has to be 7, or x has to be 3. Okay. Go ahead and do one more here. So this one is already in standard form, so we don't have to move anything around. And I'm just going to go ahead and factor it now. Now again, it's important to note that not all quadratic equations can be done using factoring. So you will eventually learn other methods to solve those, but if you can factor it, then it's generally the way to go. And now here, I know this times this has to be a negative number, and there's only one way to multiply to a negative number, and that's if we have one of each. Okay, and then the factor pair of -15, that will add to 14, positive 14. Well, that's going to be positive 15 and -1, right? 15 times -1 is -15, and 15 plus -1 is positive 14. All right, and now either this factor needs to be 0, or this factor needs to be 0 because of the zero product property. go ahead and solve both of these for x. Subtract 15 from both sides here. Then we'll add 1 to both sides there. And so those are your two solutions for these quadratics. All right, and with that said, guys, it's been demonstrated.